Hey guys, so we're gonna start the next set of notes on Unit 7, Day 4. So remember, the entire unit is about those sine, cosine, and tangent trigonometry functions. So you gotta remember the SOHCAHTOA. So that's the most important piece there, is remembering that SOHCAHTOA. I'll provide for you guys in the documents the cheat sheet that you would be using if we were in class right now, but we're not. So here's a little refresher at the top of your notes page. The sine of theta is opposite over hypotenuse. That's the SO part. And the cosine of theta is adjacent over hypotenuse. And then the tan of theta is opposite over adjacent. And that's the TOA part. So you either got to remember these or use your cheat sheet for these so you can try to figure it out. But remember, these only work with right triangles. Same with the Pythagorean theorem. We can't forget that one. So leg squared plus leg squared equals hypotenuse squared. So if we're trying to find this side, AB, we're going to call it X. We're going to set it up. Remember, 3 is a leg and 5 is the hypotenuse. X is another leg. So set up your equation. So we have 3 squared plus x squared is equal to 5 squared. 3 squared is 9 plus x squared is equal to 25. And then we need to subtract the 9 from both sides. So x squared is 16. And don't forget to square root in the end. This one comes out nice. X is 4. Okay, so that's how we find the side. So now we're going to use all this information to be able to solve these problems that you're going to see in ALEKS using the trig function. So the sine, the cosine, or tangent. So the question is going to ask you to find either the cosine, the sine, or the tangent of the angle. And you have to give it as an exact value, which means, remember those radicals, your answer should have a square root in it and not a decimal. So when we're trying to solve this first one, the first one says cosine of theta is what we're trying to find. Well, cosine of theta, remember, is ka, which is adjacent over hypotenuse. So 13 is the hypotenuse. We've got that. But 12 is the opposite side. We need to find this adjacent side. So first, we're going to do the Pythagorean theorem. So we've got x squared plus 12 squared is equal to 13 squared. So 12 squared is 144. So we've got x squared plus 144 is equal to 169. And then we need to subtract the 144 from both sides. And x squared is equal to 25. Square root both sides, and x is 5. So now we know that the adjacent side is 5. So when we write our final answer, we're going to say cosine theta is equal to, the adjacent is 5, so that's your A, and over the hypotenuse is 13. And we're just going to leave it like that. So the next one asks you to find, so this is your final answer. You just need to write it as a fraction. This one doesn't happen to ask for the square roots. In the next example, they ask us to find sine of theta. Okay, so remember, sine of theta is SO, which is opposite over hypotenuse. So let's look at what we've got. 15 is the opposite of that theta because it's across from it. And 8 is next to that theta, so that's adjacent. So we need to find what the hypotenuse is. So Pythagorean, we've got a leg is 8 squared plus another leg is 15 squared. And that's equal to x squared because we have to find the hypotenuse. So 8 squared is 64. 15 squared is 225. and that's equal to x squared. So if we add those together, 225 and 64 make 289, which is equal to x squared. And if you square root 289, you get 17. So square root both sides, square root both sides. X is 17. All right, now that we found the hypotenuse is 17, we can now set up our answer. So our answer is asking for sine of theta. So we say sine theta equals, opposite is 15 over hypotenuse is 17. Done. So our answers are going to be fractions here. Now if we take a look at the next page notes, we have that sometimes it's going to give the angle measure, but you can still use the trig functions to solve. So sometimes it's going to give a picture of the angle measure, and you have to try to find x in each of the triangles. And it does want you to round your answer here to the nearest tenth. So let's try this out using our trig functions. So first of all, let's label what we have. 15 is the hypotenuse, so that's our h, and x is opposite of that angle, 49 degrees. So that tells me I'm going to use sine because that stands for the SO in SOHCAHTOA. So when I set this up, I'm going to say sine of 49 degrees is equal to, opposite is x, over hypotenuse is 15. Now, we all find it pretty easy to cross multiply. So what I'm going to have you do here to solve for x in order to get x by itself is put the sine of 49 over 1 and cross multiply. So cross multiply. Okay, so if I cross multiply, I've got x equals 15 times the sine of 49 degrees. And what you're going to do is you're going to put that in your calculator. So you're going to say 15 times sine of 49. Now, if you're doing your calculator on your phone, then you can type in 49 and hit sine, and then times that by 15. So home calculator, you would have to do this part first. Okay, and then multiply it by 15. So we should get x is equal to, we have to round to the nearest tenth, 11.3. That would be our final answer there. So let's try this next example. So again, x is across from the 50, so that is O. That's the opposite. And 6 is next to the 50-degree angle, so that's called adjacent. So that's A. So the only one in our trig functions that does opposite over adjacent is tan. So we're going to set up our equation. Let me move this over so that I have some more room. And if we set up our equation, we have tan of 50 degrees, because that's what's the angle in the corner, is equal to, opposite is x, over adjacent is 6. So again, same thing. Let's put tan over 1 and cross multiply. So we get x equals 6 times the tan of 50 degrees. So again, when you're putting this in your calculator on your phone, you're going to hit 50 first and then tan and times it by 6. So x should equal 7.2. That one ended up rounding up. Remember, when you're rounding to the nearest tenth, you got to look for the second number after the decimal point to be able to round it up. Okay, so there's our two answers for example number 3. Example number 4 is pretty much the same thing, but it has pictures of houses and kites. That's the only difference between the two. There's word problems and then there's non-word problems, right? So this one still gives you a picture of a right triangle, so it still can be done with the trig functions. So let's look at what we've got. They want us to find the hypotenuse. The question mark is the h, the hypotenuse. And in relation to 70, the 16 is the adjacent. So out of our trig functions, we're going to use CA, which stands for the cosine. So set it up. cosine of 70 degrees is equal to adjacent is 16 over hypotenuse, which we're going to call x. So again, put cosine over 1 and we're going to cross multiply. Watch what happens here. We have x times cosine of 70 is equal to 16 this time. So now, in order to get x by itself, the opposite of multiplying is dividing. So we're going to divide both sides by cosine of 70 because we need to get rid of it. Okay? So let's try this in our calculator here. So in order to do this one, you're going to have to, if you're going to use your calculator that you have on your phone, you're going to have to punch in 70 first and cosine to get an estimate of about 3.342. And then you're going to have to clear and divide 16 by 0.342 to get an answer of about. So x is going to be about, sorry, my pencil wasn't working for a second there. X is going to be 46.8 degrees. So again, if you're using your phone calculator, you're going to have to punch in the cosine first, figure out what it is as a decimal and approximate it, and then divide. But you can go online and try to look up on Google or anything that has another calculator, 16 divided by cosine of 70, and you should get something similar. All right, so one more problem. This is the last one in the notes for today. So that's about 3 or so topics today. All right, so this one we have 83 is across from the 65-degree angle, so that means it must be the opposite. And then they want us to find the hypotenuse. So for this one, we know that opposite and hypotenuse is SO, which stands for the sine. So we set up our equation. Sine of 65 degrees is equal to, opposite is 83 over hypotenuse, which is x. So this is very similar to the previous problem. Again, we put the sine over 1 and we cross multiply. So watch what happens. We have x times sine of 65 degrees is equal to 83. So very similar to the last equation. Let me move down so that I can have some more room to write. So in order to get x by itself, remember it's being multiplied by sine of 65. So opposite of multiplying is dividing. So we're going to divide by the sine of 65. So x is equal to 83 divided by the sine of 65. Again, you can probably try to Google this, or you can do an estimate of the bottom. So in your calculator on your phone, you're going to type in 65 and hit sine. And we should get something along the lines of, I'm going to call it 0.906. And now I'm going to clear my calculator and divide 83 by 0.906. And I should get x to be about 91.7 because they want us to round to the nearest tenth. All right, so hopefully these notes help and you guys can try it out. If you have a printer at home, maybe you can print out some of the notes and try copying it down yourself to get a better understanding. That's totally up to you. You can pause and stop this video as necessary. Let me know if you have any questions. You can ask me on Google Classroom. You can ask me on Alex even, or you can ask me via email. Or we could even set up a Zoom conference if you're really struggling. So let me know. Good luck, guys. Hopefully see you soon.